First of all, I have to say sorry for this delay because of we had a technical issue. A very good evening to everyone. I'm 𝗤𝗍 signing in as our moderator of today's session. The 𝗖𝗵𝗽 student branch of Sri Lanka Technological Campus presents Road to Code Mania 22 consecutively for the second time. Road to Code Mania is a project that includes 4 informative webinars on procedural C programming. Today, we have Mr. Yohan Pandigama as our keynote speaker, lecturer CS at SLTC, MCS, bit creator and chief programmer of 𝗦 Framework 2.0. So today, he will be providing us with an informative session on algorithm design techniques. Before handing over this platform to our keynote speaker, I have some special announcements about the future events. At the end of the workshop series, we will be conducting a quiz based on a real-life scenario using the HackerRank platform. And the approved answers will given workshop knowledge will be awarded an e-certificate. The registered participants will be informed about the date and details of the quiz via email soon. Let me give you a brief idea about the HackerRank coding platform. HackerRank is a leading coding challenge website aimed at 2 main audiences: companies looking to hire high-skilled developers and software engineers looking to develop coding skills and prepare for technical job interviews. Thank you, sir, for your patience. So now I kindly invite Mr. Yohan Pandigama to conduct this session on algorithm design techniques. Over to you, sir.
Thank you. Good evening, everyone. Algorithm design techniques, that's our topic for today. My name is Yohan Pandigama. I'm a lecturer at SLTC Research University. With me, I have Sahan Kaushalya, a second year undergraduate of SLTC Research University. So let us straight away go to the agenda of the day. Introduction, some algorithm design techniques, their application, summary and conclusion. So these are the things we are going to talk about today. Let us go to the introduction straight away. Algorithm design techniques. When you hear about the topic, you might probably get a certain idea. But this is what Wikipedia has to say about it. Algorithm design refers to a method or a mathematical process for problem solving. To make it simple, we can tell you, algorithm design techniques are methods that will enable you to attack a problem. In other words, that will enable you to give solutions to certain problems. Algorithm design techniques are not solutions. They are basically creating the environment for you to attack the problem, to give a solution. So that's why Wikipedia says algorithm. Actually, they are the starting point of most of the complex things, advanced things. You start naive. That's what we can say. considering our little experience. Brute force, even though it's very naive, that could be considered as the starting point of many other algorithm design techniques that we use today. So Wikipedia, again, Wikipedia says it's a general problem solving technique, an algorithmic paradigm that consists of a systematically enumerating all possible candidates for the solution and checking whether each candidate satisfies the problem state. I will put it into my word and our words. In a brute force, you try out all the possibilities, right? You list down all the possibilities, starting from one end, you try out each one at a time, right? Until you find the solution. So in a brute force, you will try everything from one end to the other end, one by one, until you find the solution, until you find something similar to the solution that you expect. And when you are happy with it, you will stop it. Guess approximation. We can tell you that guess approximation is an improved, an enhanced version of the brute force. In the guess approximation, you start with a guess, all right? Because when the solution is not clear, you can't you can try out everything, but it takes time, all right? It takes time. So if the time consumption is of some importance to you, you can start with a guess, right? And then you can apply this guess to some algorithm that you already have. An algorithm that you think is going to get you the answer for this problem, right? And remember, this is an algorithm that you think is going to get you the answer for this. So you start with an algorithm and you apply that guess into that algorithm and see if that algorithm with that guess can return the expected solution. If it returns the expected solution, you are lucky because your first try, your first attempt is a winner. You are a lucky student or lucky fellow. You can stop it. If your guess is not right, then you have to approximate. Now this time you are approximating, right? You are trying to make another guess, but it is not something that you pick out from a list, like in guess approximate, like in brute force. Now this time, looking at your guess and where it had hit with respect to the answer, with respect to the solution, you are approximating your earlier guess with an approximation algorithm, and you are trying to create a new guess. Now this process repeats until you hit the right target. That means until you arrive to the solution, no, that you arrive to something that you can be happy about as a solution. That is guess approximation. One of the very handy techniques, very powerful techniques, an improved version of brute force. And then we look at divide and conquer. As the name implies, again, divide and conquer, first step is to divide the problem. Now here we are dividing recursively. You will see what recursion is when we talk about the next slide. But for the time being, look at the diagram, right? If the problem is large and if it is complex, you try to break it into pieces. You divide. What should be the size of a piece? That is up to you. No one can give you any standard, any guideline about the size of the piece. That totally depends on the problem solver. If you think some particular amount of description is going to create a part of your problem, you go for it, right? In a divide and conquer algorithm, we break the problem into pieces, and then those broken pieces, we conquer them individually. And finally, you are going to merge them together in order to arrive into the solution of the whole, right? Creating solutions for the part and then merging them together in order to arrive into the whole, the solution. So in divide and conquer, it recursively breaks down a problem into two or more subproblems. It doesn't need to be two always, it could be two or more of the same or related type until these become simple enough to be solved effectively. If you can find the recursive component in your problem, you are very, very lucky. Okay? If you can find a recursive component when you divide, you are very, very lucky. Because you can save a lot of time, as we are going to show you somewhere later in our presentation. Recursion. We all know a function can call itself, right? A function means one of those broken down pieces, right? A function can be considered as one of those broken down pieces. Now, recursion is a common mathematical and programming concept. That means the function can call itself, right? Look at the diagram, please. Look at the diagram, please. This snake is trying to eat him, right? He's starting from his tail, trying to eat him. Can you imagine what could have happened? What would probably happen at the end of eating? That is, we will let that for your imagination. A function can call itself. Recursion is a common mathematical and programming concept. That means a function can call itself. This has the benefit of meaning that you can loop through data to reach a result. Let me put it into terms, my own terms, our own terms. For you to use recursion, you have to find the recursive nature of the problem. How do you get the recursive nature? How you can understand the recursive nature? I would say that comes with your experience. You have to be patient for that, right? That comes with your experience. You have to find the recursive component, recursive part of the problem, and then you can apply recursion. There has to be, remember, there has to be a base case, otherwise it will never stop, right? Your recursive solution must talk about a base case, right? When the base case is found, the algorithm stops. Otherwise, it will loop forever, right? It will continue forever. Greedy algorithms. As the name implies, here we are being greedy. When we solve the problem, when there are different solutions available, we are being greedy. We take the solution that we think is best at that time. It may not be the best thing for the whole problem, but that we think best at that time. As humans, when we solve problems, we use this, right? Any algorithm that follows the problem solving heuristic of making the locally optimal at each stage, one at a time. Look at the diagram. Now you are at this building, starting location, and you have three paths to select. One of three has to be selected. First one, from your starting location to city A, it's 15, maybe kilometers, I don't know. We don't know. 15. And then we have 25 to city D. And then we have 10 for some city. Our destination is after that. So looking at 15, 10 and 25, you are going for the shortest because traveling has to be short in order for you to get benefits, right? We are going for the shortest. So 15, 25, 10, shortest would be 10. We take that. We are not worried about the whole problem, right? The shortest of the entire map, we are not worried about it. Whatever is presented, three things are presented, out of which what is found to be best at that moment. What is that moment? Now you are at the starting location. At this moment, what is best for you is to take 10 and go to city B. And when you are in city B, you have two options. One is 20, one is 2. If you want to go to destination here, out of 20 and 2, you would pick 2. That means you would go to city F. Now, when you are in city F, how many options you have? You have 7 for destination, you have 19 for city E, you have 2 for city B. Actually, you came through city B, no need to go back here. 2, 7, 19, you pick 7 here, right? That way you go to the destination. So at the end of the total journey, what will be your result? From starting to city B, 10, from there to city F, 2, finally 7, 19. Right. So here we have taken a greedy approach. Now let us have a look at the application. Now all these applications are, all these codes that have been used to develop these applications are done in C programming language. These are our examples, the examples that we use during teaching in our classrooms. Okay, now let us have the application. Let us look at the application. Now, first one is suitcase unlocking problem. This is one of those popular problems for all of us at SLTC. I will brief you about the problem description. I think you may have already seen those very old suitcases where you can lock the suitcase by giving a 3-digit number. And for you to give those 3 digits, there are 3 knobs available. Each knob is numbered, labeled from 0 to 9. So knob 1 has 0 to 9, knob 2 has 0 to 9, knob 3 has 0 to 9. So when you lock the suitcase, you randomly pick a number and lock the suitcase. Say for an example, you pick 1 from knob 1, 2 from knob 2, 3 from knob 3, 123. And then you lock the suitcase. So for anyone to unlock this suitcase, assuming that the particular person, the person who's going to unlock this, has all the time in the world, how long would it take? How many attempts would it take? Maximum. 3 knobs, each knob 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options, 0 to 9, 0 to 9, 10, 10, 10, 10 into 10 into 10, maximum 1000 tries. Okay, maximum 1000 tries, answer should come, right? Unlocking should happen. Maximum 1000 tries. So we give him ample time, all the time in the world. So unlocking the suitcase is not a problem, all the time. But in the real world, we don't get all the time in the world. It's a different story. But assuming for this example, for the sake of this example, we will assume he has all the time in the world to unlock this suitcase. We run a brute force, right? We run a brute force algorithm. Now look at this. We are making use of 3 for loops. Making use of 3 for loops, each one starting from 0, going up to 9. Now, what is the lock code? Lock code is 123, as you could see. What happens when the algorithm runs? What happens when the algorithm runs? Code matched, proceeding to unlock. We have found 1, 2, 3 at 124th match comparison. Right? Now let's go to the code. Let's go to the code. Now here we run 3 for loops. 4 from 0 to 9 and not found. And the other one 0 to 9 not found and not found. Third one 0 to 9 while it is not found. When you find it, you set found variable to 1 because once you find it, once you have found it, There's no requirement for you to check again, right? You stop it. For you to come out of the loops, all three loops, we put the flag found there. When you found the answer, you set it to 1 and you come out of all the loops. And once you come out of all the loops, you simply print what you want to print and then you return 0 and then you end the program. So as you could see, this is a very simple, very naive algorithm, but it shows you the idea behind a brute force. Now let us go to guess approximation. Now in this guess approximation application, we are trying to show you an approach to find the square root of a number. As we all know, there's no formula to find the square root of a number. But there is a formula to square a number. To get the square value of a number, you have a formula. If you multiply the number by the same number, you will get the square value. But there's no clear-cut formula to find the square root of a number, right? If you can simply go back to your grade 3 at school, you will agree with me, right? My teacher can straight away tell the square root of a particular number, but I cannot. I couldn't. The reason being, teacher knows the square root because she has done it before. Me, being a novice, being a very amateur, I find it very difficult to find the square root straight away. So if you really want to come out of this tragedy of finding the square root, why my teacher can do but I cannot do. If you really want to come out of this, you'll need to come up with an algorithm, something similar to this. Something similar to this. That means to say you can have your own. What we do is, when the target is given to find the square root, because we don't know the square root, we start with a guess, right? We start with a guess. And that guess, we put it to the known formula. What is the known formula? When you multiply a number by the same number, it gives you the square value. The square root is that number that you use to multiply, right? So when you multiply a number by the same number, it gives you the square value. The square root of a particular number is the number that you use to multiply by the same number. All right. So we know our guess, when multiplied by the guess, if we are happy and successful, if we are lucky and successful, we should hit the target. Right? So let us find out. We'll run the algorithm. Sahan will run the algorithm for us now. Let's say we want to find the square root of 25. Square root of 25. We'll start with the guess, 3. My guess is 3. Now when 3 is multiplied by 3, we'll end up with 9. Our first try is 9. Here, I'm making a new guess. According to my approximation algorithm, my new guess is 5.28 something. I put into the formula, known formula. Then the answer is 27. I make a new guess. Then it becomes 5.11 something. I put it to the formula. I end up with 26. I make a new guess. This time 5.02. I put it to the formula. I have rounded off the answer to the whole number. I end up with 25. So that means my final guess is 5. 5.02. It's very closer to 5, right? So that is my final guess. We can run it another time, and this time we can give a different number. Say for an example, 100. You can start with the same guess if you want, 3, right? What happens? 3 into 3 is 9. You make a new guess. According to your approximation algorithm, it becomes 16. 16 into 16, 256. Make a new guess. It's 11.27, 127. 10.1, 102, 10.0, close enough, our final guess is 10. Let's go to the code. You look at this, you find out our answer should be guess multiplied into guess, right? While my answer is not the target, I have to try, right? I have to try this. While my answer is not the not the target, I have to try. So when I try, my guess has to run through an approximation algorithm. In line number 20, what you see is that approximation algorithm. You can have your own approximation algorithm, no problem. I have used this because when I go through those square root values on a piece of paper with a pencil, I was able to find out this pattern, right? You can have your own pattern for any problem of this nature. So likewise, this will continue to happen until a close enough answer is found. Let's go to divide and conquer. Now this is a very popular example. You can find it. You can find this on any textbook about data structures algorithm. The popular binary chop or binary search algorithm. Now in this binary search algorithm, we are trying to show you the use of divide and conquer. Remember, here I have not used recursion. I have used a while loop. You can write the same thing using recursion. We will let you do as a homework. Implementing this as a recursive function, we will let you do it as a homework. But we have used here a while loop. We will run the algorithm. Here we are looking at, we are going to search value 9 in this list of ARR, right? Line number 14, ARR. You know there is a list. The list is already sorted from smallest to the largest. We are going to look at 14 here. We are going to try and find out whether 14 is here, whether 14 is existed here. All right. Okay. So let's start our binary chop using divide and conquer. It says item found at position 10. So let us see, let us go through the array and find out whether 14 is at position 10. Minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 16, 23, 27, 100 and 100. Sorry, we are searching for 9, okay? We are searching for 9. Sorry, I think I must have made a mistake. We are searching for 9. So, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Position 10. So, let us look at the output. Let us look at the output. Item found at position 10. Now, shall we go to the code? And this time, can you set item to find as 0? As 0. Now, let's see what our algorithm can do for us. Item found at position 1. I hope it is clear to you. Now, let's go to the algorithm and try and have a look at divide and conquer. Now here what we are doing is we are trying to divide the array into 2 at each successive iteration. Now when you start, how many numbers you have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. When you divide 15 elements into 2, you get 7 to left hand, 7 to right hand, and there's a mid one, which we call P or pivot, mid one. And since the array is sorted, you can decide, looking at the item to search, you can decide whether the item to search is less than the pivot value or greater than. If it is less than the pivot value, you can forget about the whole right side. If it is greater than the pivot value, you can forget about the whole left side. Right? So that way you can clearly see, we suppose your array is becoming half the size of your original array each successive time, each successive iteration. This makes this algorithm much faster. But remember, the array has to be sorted, otherwise you can't do this. This makes this algorithm much faster. Much faster method, but there is a precondition. However, we are able to show you the application of recursion because this problem has this recursive property here. Because you are trying to do the same thing again and again. Only thing is your list can become larger. Right? Only thing is your list can become larger. But what you are trying to prove is the same method of approach. Right? Same approach. Right? So we are starting while the start is less than or equals to end and found is 0, and you get the pivot, you calculate the pivot and you see whether the value is pivot. If that is the case, you are a lucky person, found, and you stop your work. Otherwise, you see your item to search is in the left side of the pivot or else the right side of the pivot. So that way you reduce your original size of the array into half, and with that half you now assume the half what you retain now is the problem, and you apply the same procedure again. Again it will become half if it is not the pivot. Now you can decide whether it goes to the left side or right side. Continue up until you get the answer. If there is an answer, you should get this answer. Otherwise, it should tell you the item to find is not available in the list. Let us now go to recursion. Right. This is also a very popular example available in almost all the textbooks and many web material if you refer. What we are trying to do is we are trying to find the factorial of number 5. Right? Factorial of 5. We know the factorial of 5 is how to get the factorial of 5. 5 into 4 into 3 into 2 into 1, which will give you 120. Right? The base case, remember, there has to be a base case. The base case here is 1 or 0. Right? First, we'll have to write the base case. In fact, we start a function. We pass the number. Here's the base case. If n equals to 0 or n equals to 1. If n is 0 or n is 1, we say f is 1. And we stop there. When n becomes 0 or when n becomes 1, we say the value of f is 1 and that is the base case. Otherwise, f equals to n into the factorial of n minus 1. So this way you can see in line number 12, n into factorial n minus 1 means we are calling the factorial function, fact function, this time with a new value. Same solution steps, but this time with a new problem, right? A reduced version of your problem, right? So it will call it again. Now what will happen? First time you pass 5, not n is not 0, then 5 into fact 4. What is fact 4? Again fact, right? N is not 0. 4 into fact 3. Fact 3, not 0. 3 into fact 2. Fact 2, not 0. 2 into fact 1. Fact 1, not 0, but 1 is 1. So that means 5 into 4 into 3 into 2 into 1. It should return you 120. Let us run the program and see. There's an error? No. There's a warning, Right, don't worry about the warning. We have got the answer. Factorial of 5 is 120, right? Okay, don't worry about the warning. We have got the answer. Factorial of 5 is 120. So let's go to the code again. Let's go to the code. Let us now make factorial of 3. Factorial of 3 is, let us say fact3. Call fact3. Call fact3. Now save and run the algorithm. Factorial 3 is 6. 3 into 2 into 1. Right. Let us run again. Let us run again. Factorial 100. Not 100. Let's say factorial of 10. Fact 10. Save. We run the program. Some big number. San, can you read the number? It's a huge number, right? 3,628,800. Is it? Something like that. Okay, great. That will enable us to now go to greedy algorithm. Now greedy, now you have gone through brute force, just approximation, divide and conquer, recursion. Now you have some idea, we believe. So you have the idea of greedy, how greedy algorithm works. We would like to give it as a homework for you. Write the greedy algorithm in any language that is comfortable to you at home and enjoy its working. Now let us go to the presentation again. Let's go to the summary. Here's the summary. We started with, okay, we started with the idea, the main idea of algorithm design techniques, right? What is algorithm design? What do you mean by a technique? All sort of things. And then we had a look at the definition of brute force, guess approximation, divide and conquer, recursion, greedy algorithms. And then we had a look at the implementation, the application, brute force. Remember our popular suitcase unlocking problem. Yes, approximation. Remember our popular find the square root of a number algorithm. Divide and conquer. Remember popular binary chop, binary search. Recursion. Remember popular factorial, finding the factorial of a number. Greedy as a homework. So this is the summary of our short presentation for today. Our idea was to give you an introduction into algorithm design techniques. As you agree with us, as you would agree with us, this is going to be only the start of a long journey. Start of a long journey. Take this start as a positive start, work hard, and you will be able to master the art of programming, master the science of programming very soon. With these things as support material for you, background, foundational material for you. These are the basics of computer science. Even though these are basics, these are going to be there forever because almost all the other things are built upon the basics. So with those, with this message, we would like to wish you for a wonderful night and a wonderful weekend ahead. That's it from our end. My name is Yohan, and with me I have Sahan. We are signing off from FF3 group number FF3 at SLTC Research University, Pakistan. Good night.
I'm sure that was a great session for all of us. Thank you, Mr. Yohan Pandigama. The session on algorithm design techniques has been delivered in the most productive way by our speaker, as I see. And I hope all the participants have gained some valuable knowledge on today's content. This day would not be very productive without you, sir. So this is the time to pay gratitude. So please accept this token of appreciation. Thank you, sir. So once again, I thank you, Mr. Yohan Pandigama, for this productive session and for spending his valuable time here with us today. And another special announcement about the participation Google form. Please fill out the form to confirm your participation in the session. Now I invite Mr. Lakitha Madanayake to conduct an effective tutorial session on HackerRank platform. Over to you, Mr. Lakitha Madanayake.
Yeah. Hi, guys. Jani, am I audible?
Yeah, sure.
All right. Okay. So hope you can see me as well. And right. මම කරන්නම් අපේ hacker rank එක ගැන පොඩි basic idea එකක් දෙන්න ඔයාලට. Right. Can someone stop the screen sharing? Chanuka? Right. හරි. මම පොඩි idea එකක් දෙන්නම් hacker rank එක ගැන. අපි දැන් අපි ඉගෙන ගත්ත දේවල් වලින් coding practice වෙන්න හොඳම platform එකක් විදිහට hacker rank එක අපිට කියන්න පුළුවන්. එතකොට මම කියන්න hacker rank එකේ කොහොමද අපි codes ලියන්නේ කොහොමද practice වෙන්නේ කියලා. මුලින්ම අපි hacker rank කියන website එකට Google එක හරහා ගිහිල්ලා hope you guys can see my screen as well, right? Jani, can you confirm that?
Yeah, I can see.
Nice. Okay. All right. හරි අපිට දැන් වෙබ්සයිට් එකට ගිය ගාම තියෙන්නේ sign up වෙන්න. එතකොට තියෙන උඩ click කරලා login button එක ඔබලා අපි practice වෙන්න යන නිසා අපිට තියෙන්නේ login as a developer. එතකොට developer side එකෙන් තමයි login වෙන්න ඕනේ. ඔයාලට දැන්ටම account එකක් තියෙනවා නම් login වෙන්න පුළුවන්. නැත්නම් Google account එකක් කරා ඔයාලට login වෙන්න පුළුවන්. එතකොට platform එකට ගිය ගාම අපිට තියෙන්නේ hacker ranking interface එක of course. හරි. දැන් අපි ඉගෙන ගත්ත දේවල් ඉගෙන ගත්තේ language C එකෙන්. එතකොට ඔයාලට පුළුවන් data structures C language එක හරහා පාවිච්චි කරන්න. නැත්නම් ඔයාලට වෙන language එක knowledge එකක් තියෙනවා නම් ඔයාලට data structures and algorithms ඔයාලට ඒ language එකෙන් use කරලා බලන්න පුළුවන්. හරි. එතකොට අපි බලමු කොහොමද අපේ quizzes වලටයි competitions වලටයි participate කරන්න කියලා. අපි පල්ලෙහාට scroll කරන් ගියාම ඒකේ තියෙනවා topics quizzes මේ වගේ topics වලට කැඩිලා තියෙනවා. ඒතර අපි දැන් දන්නවා අපි data structures තමයි ඉගෙන ගත්තේ. අපිට ඕන data structures category එකට ගිහිල්ලා අපිට තියෙන අපි ඉගෙන ගත්ත arrays 2D arrays ඒ වගේ ඒවා ඔක්කොම තියෙනවා මේක අත්තම් බැලුවොත් queues stacks graphs trees හැමදේම තියෙනවා මේකේ. ඔයාලට පුළුවන් එකින් එක solve challenge කියන button එක click කරලා ගිහිල්ලා code කරලා code එක run කරලා solve කරලා බලන්න. ඒවා try කරලා බලන්න. එතකොට මම පෙන්නන්නම් එකක්. එතකොට අපි ඉගෙන ගත්ත C language. C language එකේ අපේ competition එක බලුවොත් දැන්ට බලමු මේක sum and difference of two numbers. හරි. දැන් අපිට මෙහෙමයි තියෙන්නේ. දැන් අපිට සාමාන්‍යයෙන් coding අපි IEEE extreme හරි Mora extreme හරි ඒ වගේ competition එකක් ගත්තාම අපිට මුලින්ම හම්බෙන්නේ මෙන්න මේ වගේ question එකක්. අපි මේ question එකේ format එක දාගෙන ඉන්න ඕනේ. ඒක code කරන්න ඕන. එතකොට මුලින්ම මේ question එකේ තියෙන විදිහට මම දැන් time එක නිසා මම question එකේ තියෙන දේ දන්න නිසා මම ඉක්මනට ඔයාලට explain කරන්නම්. එතකොට මේකේ තියෙන්නේ අපි ගන්න ඕනේ input එකක් මේ විදිහට 10 4 4.0 2.0 විදිහට input එකක් ගන්න ඕනේ. ඊපස්සේ අපි output කරන්න ඕනේ ඒකේ summation එක ගැන ඒක subtraction එක තමයි output කරන්න ඕනේ. එතකොට දැන් 10 and 4 තියෙද්දි 10 plus 4 14, 10 minus 4 6. ඒ වගේ 4.0 2.0 වගේ floating numbers. ඒ කියන්නේ දශම ස්ථානයක් තියෙන number එකක් ආවම අපේ උත්තරේ එන්න ඕනේ 6.0. ඒ කියන්නේ 4 plus 2 is 6 and 2 is the subtraction of 4 and 2. අන්න ඒ වගේ output එක එන්න ඕනේ. දැන් අපිට පේනවා ඇති අපේ input එක මේ විදියට ගන්න ඕනේ. අපි මේ input එක ගන්න ඕන විදියට අපි මුලින්ම අපේ code එක හදා ගන්න ඕනේ. ඒ කියන්නේ අපි input එකක් ගන්න විදියට අපේ code එක ලියා ගන්න ඕනේ. right. හරි. මම මේක කරලා පෙන්නන්නම් ටක් ගාලා. මුලින්ම අපි දන්නවා C වලින් පටන් ගද්දී අපි library එක include කරගෙන ඉන්න ඕනේ. include stdio.h අපි හැමෝම දන්න library එක. ඊට පස්සේ main function එක ඇතුලේ right. මුලින්ම කරන්න ඕනේ දේ තමයි අපි දැන් මෙතන තියෙනවා variables 4ක්. 10 4 4.0 2.0 variables 4ක් තියෙනවා. ඒක නිසා අපි ඒ variables මුලින්ම define කරන් ඉන්න ඕනේ. එතකොට පළවෙනි variables දෙක integer 4 and 10 දෙක integer නිසා මම දානවා n1 and n2 කියලා. ඒ දෙක හඳුන්වලා දෙනවා. ඊළඟ දෙක floating numbers. ඒක නිසා float කියන data type එකෙන් යන්නේ f1 and f2 විදියට මට පුළුවන් ඒක initialize කරලා දෙන්න. ඊට පස්සේ අපි කරන දේ තමයි මේ input එක අපි මේකට read කරගන්න ඕනේ. අපි අපේ code එකට read කරගන්න ඕනේ අපේ input එක. ඒක කරන්නේ scanf කියන function එකෙන්. අපි printf වගේම තමයි scanf function එක. તો scanf function එකේ අපි මුලින්ම කරන්නේ අපි first line එකේ අපි ගන්නවා integers දෙකක්. එතකොට අපි දන්නවා integer එකේ ලකුණ percentage d for decimal. ඒක තමයි අපේ integer එකේ ලකුණ. ඒකම අපි දාන්න ඕනේ අපි මොන values වලටද assign කරගන්නේ කියලා. එතකොට අපි first value එක 10 කියන එක assign කරන n1 එකට. එතකොට අපි special character එකක් දානවා මෙතන at කියන එක. ඒක pointers base දෙයක්. ඒ කියන්නේ worry වෙන්න එපා. අපි දාගන්න හැටි ඔලුවට ගත්තා නම් හරි. එතකොට n1 first character එක දාන්න අපි n1 then ඊළඟ ඒ කියන්නේ 4 කියන එක දාන්නේ n2 කියන variable එකට. ඊට පස්සේ line එකේ අපි ගන්නේ floating numbers දෙකක්. එතකොට ඒකත් අපි දාගන්නවා scanf function එකක් විදියට. right. එතකොට floating numbers වල ඔයාලා දන්නවා floating numbers වල මේ syntax එක වෙන්නේ ප්‍රතිශත ලකුණයි f අකුර. හරි. අපි ඒවා දෙකක් තියෙනවා. අපි input එකකින් දෙයක් ගන්න නිසා එහෙම දැම්මා. අපි ඒවා assign කරගන්නවා. අපි ගත්ත variable f1 and f2. ඔය දෙකට assign කරලා ගන්න. දැන් හරි. දැන් අපි පළවෙනි අපේ input එකෙන් input එක read කරගත්ත අපේ code එක ඇතුළට. දැන් ඒ කැලේ done. දැන් තියෙන්නේ අපේ calculation part එක විතරයි. ඒතර අපි calculation එක වෙනම fitting කරන්න පුළුවන්. නැත්නම් අපිට අපේ printf function එක ඇතුළෙම කරන්න පුළුවන්. අපි ඒක printf function එක ඇතුළෙම කරමු ලේසි නිසා. මුලින්ම print වෙන්න ඕනේ මේ තියෙන sample output එකේ තියෙන print වෙන්න ඕන දේවල් මුලින් print වෙන 14 and 6. ඒ කියන්නේ 10 plus 4 and 10 minus 4. අපි print කරගමු ඒක. ප්‍රතිශත ලකුණයි d and ප්‍රතිශත ලකුණයි d. හරි. අපි එතකොට first එක වෙන්න ඕනේ n1 plus n2. ඒක පළවෙනි අපි pass කරන්න ඕන value එක. අනික් එක n1 minus n2. right. ඊළඟ එකත් ඒ විදිහම තමයි. ඊළඟ එක වෙනස් වෙන්නේ floating numbers නිසා විතරයි. ඒකට d වෙනුවට මෙතන f වෙනවා. මෙතන n2 n1 වෙනුවට f1 f1 and f2 එනවා. දෙවෙනි එක f1 minus f2 එනවා. ඊළඟට අපිට පුළුවන් end කරන්න අපේ code එක return 0 දීලා. right. දැන් මේක තමයි අපේ code එක. අපි run කරලා බලමු වැඩ කරනවද කියලා. alright. So there is an error. බලමු මොකක්ද error එක කියලා. right. අපි මෙතන printf එක දාද්දී line break එකක් දෙන්න ඕනේ. මොකද මෙතන 14:6යි 6.0 එක line එක print වෙන්න බැරි නිසා. right. line break එකක් දුන්නා. දැන් run කරලා බලමු. okay. alright. මෙතින් අපේ output එක. එතකොට අපේ පළවෙනි output එක හරි 14.6 හරි. දෙවෙනි එකත් හරි. හැබැයි අපේ floating point එක exceed වෙනවා. ඒ කියන්නේ zeros ගොඩක් එනවා. ඒකට අපිට කරන්න තියෙන එකම දේ මෙතන floating point එක අපි දෙනවා දශම ස්ථාන කීයක් ඕනේද කියලා. ඒ කියන්නේ 0.1 දෙනවා f එක ඉස්සරහට 0.1 and then අපේ ඕන output එක එනවා. එතකොට අපේ දශම ස්ථාන එකකට තමයි print වෙන්නේ. ඒ කියන්නේ අපේ sample test case එක ඒක done. ඊට පස්සේ තියෙන්නේ මේ වගේ පළවෙනි test case එක වගේ run වුණාම පස්සේ අපිට තියෙන්නේ submit code එක හරහා ඊළඟ test cases ටික හරියනවද කියලා බලන්න. ඊළඟ test cases ඔක්කොම හරියනවා නම් එතකොට ඔයාට ඒ code එක complete. ඔයාට 100% marks හම්බ වෙනවා. HackerRank platform එකේ. right. දැන් අපේ test cases ඔක්කොම හරි ගියා. එතකොට 100% marks හම්බ වෙනවා මේකට. ඒ වගේ මේ වගේ points අපිට add කරගන්න පුළුවන්. right. මේ වගේ points add කරගන්න පුළුවන් අපේ HackerRank එකේට. අපේ points වැඩි වෙන්න අපේ HackerRank platform එක ටිකක් recognize තත්ත්වයකටපත් වෙනවා. අපිට ඕන නම් අපේ CV එක උනත් share කරන්න පුළුවන් අපේ HackerRank platform එක. right. ඒ ටික තමයි basics HackerRank platform එක ගැන. මම හිතනවා ඔයාලට idea එකක් එන්න ඇති. So that's it for today and thank you guys.
Thank you, Mr. Lakitha Madanayake. So as I mentioned previously, all the registered participants will be informed about the date and details of the quiz via an email soon. We have now reached the end of the today's session. Hope to see you all on the day of the quiz competition. Till then, good night and have a great day. Thank you.